Yes, students, we are going to have a subject entitled Business System Simulation and Modeling. This subject is about how you can simulate a business and show how your company is working. But this is not a real thing, it is an imitation of how your system or your enterprise is currently working. So you can simulate anything. There can be any computer simulation, a flight simulation, game simulation. For example, I give you an example. When you are going to design a new flight or a car, they have to design it first. After designing it, they design it on papers. After that, they are going to put what they have designed into the computer, and then they have a car. They try to move it as if it were a real car. So you will see so many simulation games. You can have some games which are the imitation of a movie. So they can design or draw an actor in the movie and then imitate the movie using a simulation. So a simulation, it will be like a software which is going to imitate the real thing, so that when someone is seeing such imitation, they will really see a real thing. For example, here, if we have, for example, a simulation, a flight simulation, you are going to run, or you are going to drive a flight or a car in your phone. So it will be like a real car, but it is an imitation. So here, as a definition, a simulation is the imitation. The imitation of the operation of a real world process or a system over time. It means that you imitate. Imitate, it means that really you are not, we are not touching a real thing. It is an imitation of what is real. It is like an abstraction. So here we can, for example, have so many things to do. Here we see that it involves the generation and observation of an artificial history of a system, and then draw in inference about the characteristics of a real system. It means that we are going to have to observe something which is real. After that, after observing it, we are going to imitate it. So we imitate it on how it works, on how it looks. After that, someone who did not see that real thing will know about that thing without touching it. So here the simulation we are going to imitate what? The operation of what? Of your business. For example, you are having a bank. You can imitate how a bank works. You can say that, for example, the customer must enter. When they are coming to your bank, they must, for example, enter into the queue, and the one who came first will be the first served, which is called FIFO. So after that, you will say that the first one who came first will go to the cashier, and the cashier will have to serve him. So you will show how the operation will be going from the beginning till the end, from the time when the customer came to the bank till the time the customer went out. So you can write everything about what will happen in that time, from the beginning till the end. So what you are going to write, it is an imitation of the operation of the bank. And then someone can read what is going on, or how the operation for the bank are performed. And then there is no need to go there to watch how the things are going on. It is enough to see the imitation or the simulation of the bank to know how the bank operates really. So the behavior of a system is started by developing a simulation model. So we are going to show how the bank operates using a simulation model. So what is a model? A model, it is a set of assumptions about the operation of the system. So it means that the simulation model, it is an assumption. It means it is an imitation. It is not it doesn't look totally the same as the real operation. So we are going to have an approximation, but almost the operation of the simulation will look like the real operation. So these assumptions are expressed in the mathematical, logical, and symbolic relationship between the entity and the object of the system. It means that these are assumptions. We are going to express this assumption in using mathematics. You can also use logics, or you can use also symbols. So you can use any means which can be understood by the people, so that they can understand really how your system is working. So we can have a real system, and the real system can be imitated using mathematical and logical or symbolic relationship. I can have a mathematical expression. I can have any mean, so that I have to convince the reader of my simulation. So when you have finished developing your system, your simulation, you have to validate it. To validate it, it means that what you have to do, you have to check about what you have developed is valid. Valid means that you are going to see that the data you are having are valid. It means that they meet, or they are almost the same, the real thing. So it means that a model can be used to investigate a variety of questions about real system. It means that a model will be used to check different problem. So if you are having a problem, it means that you are having questions which must be answered. Which question? About the real system. It means that I am having a bank. I am going to design a model. This model is a simulation which is going to imitate the real bank, how it is working. So I am having the question. For example, I ask myself, how do you handle the customer? We are having 1,000 customers. This is a question. But to answer this question, you can say, a bank manager can say, in order to manage such customers, you have to put them into a queue. So first we will serve the first one who came, and then the second one, and so on. That question has been answered using a simulation. So I can design some people and show how they come into the system, and design also the cashier and show how the cashier is serving such people in a no doubt manner. After that, after designing such a system using symbols or using figures, someone can see how the operation for the bank are being performed without going to the bank itself. So in order to make sure that what you have simulated is almost the same of what is real, you have to validate it. Validating it means that you have to compare the real thing with the simulated thing. If they are almost the same, it means that okay, your simulation is okay. Otherwise, you will say that the simulation is invalid. So, doing so, the analyst tool, we must have an analyst tool, a tool which is going to analyze and predict the effect of change to existing system. When you are having a system, there will be some changes within your system. So you have to predict that there may be some changes, because when we are simulating, don't think that things will continue to be the same. There may be some changes. So you have to have a tool which will analyze your system and predict if there will be the change to your system. So you have it also to make such changes in your simulation also, in order that the results reflects the real results. So you can have also a design tool. This will predict the performance of the new system under different circumstances. It means that after that, if there are changes in your system, there will be also the change in the performance of the new system. It means that you are having an existing system which is going to change. After changing, it will become a new system. So the performance of the new system is different from the performances of the previous system. That is why there must be two tools. The first one is going, the analysis tool will predict the change into the existing system and the effect will bring to the system. The design tool will predict the performance, because the performance will change also. This tool will going to predict how the new system will change in terms of performance. So we are going to have a simulation model. A simulation model will be used to solve using mathematical methods. It means that anything can be represented mathematically. So if I say simulation model, this model will be going to use mathematical methods. So it means that the solution will consist of one or more numerical parameters. It means that when we are having a simulation model, it is a set of solutions. Those solutions must have different numerical parameters. For example, we can measure the performance of the system. For example, we are going to see. We say that, for example, we are having a system, a manual system, where students are applying for the new intake by using manual system. For example, they have to write a request using a sheet of paper with a pen. This is a manual system. So you can check the performance of the manual system, and you're going to say that the manual system, the performance of manual system is 40%, because there will be so many mistakes. if you are going to have a handwritten request, they will be also time consuming. So the performance is very low. But when we are going to automate such a system using a computer, so the time will be very less, and also there will be so few mistakes. So here I can express those changes using mathematical method. I can calculate the time. So the application, if you use a computer, the application process will take, for example, 30 minutes. But when you are using a pen, it can take 2 hours. So we can compare those two performances using numerical parameters. So here we are using a numerical parameter, which is a measure of performance for the system. So it means that the measure of performance of the system will be the difference between the performance of the new system and the minus the performance of the old system. For example, the new system is having 80%, the old system is having 40%, the difference will be 40. But many real old systems are complex and cannot be solved mathematically. So many real old systems, some or many of them are complex. If they are complex, it will be very difficult to solve them using mathematics. So it means that we must have some other solution. So in such case, we can have a computer-based simulation. If we are having a complex system, we can have a computer-based simulation. This computer-based simulation is going to be used on a computer. It will be used to solve very complex problem about complex system. So we are going to use a mathematical model when you are having a system which is simple. When I am having a complex system, I can use a computer-based simulation. So this will be the best one. So the simulation generated data is used to estimate the measure of performance of the system. So it means that when we are having data, when you are simulating your system using computer, we are going to use a simulation software. This simulation software is going to estimate the measure of performance using the system using the software inside your computer. So those two type of simulation, the simulation model and the simulation model and the computer simulation, both are used to measure the performance of the system. So you can combine both of them, or you can use any one of them, no problem. Now we can see when you have to use a simulation and when we don't have to use simulation. So when do we have to use a simulation and when we don't have to? So when to have a simulation, when you have to use the simulation, it means there are many special purpose simulation language can be used, or methodology and tool we can use when we are simulating our system. We can use so many languages and methodologies and tools using less cost. It means that we can use very cheap tools and software using simulation languages. So here we can use simulation when we will need only low cost software, and when we are having a very high computing capability. It means when we are having computers having very high capacity to handle big data. So that in that time we can use simulation. So we can use a simulation when we are having less cost software and computer with high computing capabilities. So when it use which tool is also being discussed over the time. Here also we have to check which tool is best to use during the simulation. It means when you are going to simulate your system, you must know which is the best tool to use. Otherwise, you can use a simulation when it is not, when you don't have an appropriate tool. So when do we have to use simulation? We have to use a simulation when we want to achieve, or when we have these purposes. The first one, simulation will facilitate the study and experiment of a complex system. We will use a simulation when we want to study and experiment or check a complex system. When we are having a complex system, a very difficult system to study, you are going to use a simulation. Also, use a simulation when we are having informational, organizational, and environmental change, which can be simulated, and the effect of this alternation of models' behavior can be observed. We can use a simulation when the changes which are occurring into the system can be imitated or simulated using a computer. If you can simulate them, okay, use a simulation. Also, you can use a simulation when the knowledge gained by designing a simulation model will be useful to suggest the improvement of the system. It means that you are going to use the simulation when the knowledge we are going to have is going to help you to suggest to the manager the improvement of the system. It means that you are going to study the system and know its weakness. After knowing its weakness, you can suggest the manager what to do in order to improve the system performance. In such a time, you are going to use simulation. You can also use simulation by changing simulation inputs and observing the results output. It means that when you are studying your system using simulation, you have to input some data, and then we are going to check the output. For example, you say, when I input such data, what will be the results? So, at the time you are studying the system and see how it is performing. So, when you are doing this, you are going to check which variable are most important, or how variables can interact. Variables, it means that the data you are entering into your system, you can check which data is very important and which one are not, or how this data interact with another data. Why did I get such results or such result? So you will know more about your system. So the simulation can be used as an instructive device to support and verify analytic solution methodology. Here you can have a simulation when you want to support what? To support and verify the methodologies which are being used to do what? To provide solution to the problem in the system. It can also be used to experiment with the new design of policies prior to implementation, so as to prepare for future course of action. You can have you are going to make some new change to your system or change policies. So before designing a new system or changing its policies, you have to first experiment it. To experiment it means that you are going to check if what you are going to do if they will provide some more performance to your system, you check it using a simulation before implementing it really. So here, this will help you to prepare for future course of action. It means that this will prepare you to predict what you have to do in the future. According to the results you obtained, you can take conclusion and say, if I do this, I will get this. If I do this, I will not get this. So it will help you decide what you have to do in the future to increase the performance of your system. Also, it can be used to simulate different capabilities of a machine and to determine its requirements. Here, you are going, for example, you can say a machine can be either a motor, it can be also a car, it can be a computer. So before designing a computer, you have to simulate it. After simulating it, then you can see what is missing, what are the requirements of such a machine, and you will prepare those tools which will be required in order that your machine work perfectly. So the simulation model designed for training are running without the cost and the solution of on-the-job learning. We can simulate also. You can simulate some trainings. That means that you can train people how to use a car, how to drive a car using the simulation. So this will be at free of cost. So some people can get a simulation and which shows them how to drive a car. After that, after running the simulation, he will know totally. He won't know about how to drive a car really, but he will have some knowledge how to drive a car, so that when he's going to drive a real car, he won't start from scratch from the beginning. It means that he has some knowledge. We can also use an animation. Animation shows a system in a simulated operation so that the plan can be visualized. We can have animation. Animation, it means that you can animate, you are having some animation on TV. So this is also a simulated operation. We can simulate the people. In animation, we simulate the people, and we are going to show actors who are playing in a movie, but in an animated manner. For example, you draw a person. After doing it, you animate him. You give him a movement and sound. He can talk. He can jump like that. This is also an animation. So we can have some more modern system. For example, water fabrication plant. A water fabrication plant, it means the way you can fabricate water. Also, a service organization. These systems are very complex. So when they are complex, it means that you have to only to treat them using a simulation. If you use a mathematical model, it will be very difficult for you. You will have so many formulas. So sometimes you won't be able to simulate everything. So you have to use computer-based simulation in order to imitate such a system which are complex. So it means that having computer-based simulation, you can imitate anything. So we are going to see when the simulation is not appropriate. It means that when we don't need the simulation, computer-based simulation, when. So we will not need a computer simulation when the problem can be solved by just using common sense. It means that you are having a problem. If you are able to find a solution yourself, thinking about such problem, you can solve such problem without needing a computer or any help. So no need for simulation. You have to solve such a problem yourself using your mind. Also, the problem can be solved analytically. It means that you can analyze, you can have a problem, you have a sheet of paper, you analyze the problem. If you can analyze the problem and find a solution, okay, no need for simulation. Also, when it is also to perform direct experiments, it means that you are having a problem, you can go there to the field where the problem has occurred, and then find the problem and immediately find the solution. So no need to simulate, because you are working with a real thing. It will be also, the simulation is not appropriate when the cost exceeds savings. It means that when you are going to simulate your system, the cost of simulation, for example, the cost of simulation software, or the cost of people who will help simulate, is very high than the money you are having in your account. Or it means that the output is greater than input. It means that what is going out is greater than what is coming in. So no need to simulate. Also, you can have the source or time are not available. You don't have any time to do simulation. If you don't have time, no need to do simulation, because you don't have any time. For example, you are very busy with other tasks, so the simulation is not appropriate in that time. But you don't have, when you are not having enough data. You are going to simulate a system, but you don't have, there is some data you don't have. So if you don't have such data, but such data is very important in order to do what? In order to check the performance of the system. So if you don't have enough data, no need to do simulation. If you don't have enough time, okay, no need to go with simulation. Or don't have manpower to verify. If you don't have some people to help you verify your data, and then after the verification validate such a data or validate the model, so no need for simulation. Also, there is no need to use a simulation when there is an unreasonable expectation, like too much too soon. You can simulate your system and you will find so many results. So so many results means that you are going to analyze the results. It will be a problem for you to know really what is the real results. So in such time, no need to use simulation. Also, you can have a system which is having a behavior which is very complex. You can have a system which is very complex. For example, you are going to simulate Microsoft Windows 10. Microsoft Windows 10 is a very complex system. If you are going to simulate it, you can simulate it within 1 year without finishing. So it is very complex. Some system cannot be defined. You can go to you can want to study about the system, but you don't know many things about it. So no need. If you don't know about the system, why are you going to simulate? You are going to simulate what you don't understand. So here you can also see advantages and disadvantages of simulation. We are going to see advantages and disadvantages of simulation. Some of the advantages of simulation are advantages. The advantages of simulation are: the first one is the new policies, operating procedure, decision rules, information flow can be explored without disrupting the ongoing operation of the real system. Here you can check the policies of the system. You can see how the decision rules are being performed, or how the information flow within the system are going on. So you can study the new system without disrupting or without stopping the system. The system will continue working, and you are going to study about the system while the system is continuing going on without stopping it. It means that you study it without stopping it, because you can, some people or sometimes you can study about the system, so this requires you to stop the ongoing operation of the system in order that you can study its performance. But when you use a simulation, because the simulation is an imitation, when you are using the simulation, this won't affect the ongoing operation of your system. This is an advantage. Another one is new hardware design. Physical layouts, transportation system can be tested without committing resources for their acquisition. Here you can design a new hardware. For example, I am having a computer. The computer is having, I want to design new hardware. For example, I want to design a CD reader of my computer. So I can test a CD reader of my computer without buying it. It means without committing resources to the acquisition. It means that I don't need to buy it. I can test it using the simulation. It means that without having it. So because it is an imitation, I imitate how the CD reader works. So I won't need to buy the new hardware of such CD. Only I will test it using the simulation. After testing using the simulation, I will be able to design such hardware according to the simulation results I got. You can also have hypotheses about how or why certain phenomena occur can be tested for feasibility. I can have an hypothesis which can show me how some phenomena occurred in the system. I can test it. They can come an event which occur inside my system. I can test such event to see how I can solve such a problem very easily. For example, I can have, I'm having people are connecting the devices which consume very high electrical power. So when they connect a device which consumes a very high electrical power, what will happen? There will be some power problem. So for example, here a fuse will be switched off automatically. So I can have an hypothesis which will help me to take a decision about this phenomena which occur in my system. So which one? I can say that I have to buy a big or a very powerful fuse. Or I can say, if you want to connect a very powerful device, you have to change. You have to change a fuse. You put a very big fuse. I can take so many decisions, or I can prohibit my manager to buy very high powerful devices which consume high power. So these are the decisions I can take. So the simulation means that will help me taking decision about phenomena which are occurring inside my system. Also, the time can be compressed or expanded, allowing for speed up or slow down of the phenomena under investigation. Time can be compressed. Time can be compressed. The time it can be reduced. If I have used the simulation, it means the time I should take without using the simulation will be very low, because I am already having some results. But if I don't use the simulation, it means that it will take a long time, because I don't have any help. Or time also you can expand the time, no problem. Insight can be obtained about the interaction of a variable. Here you can see it can be clear how the variables are interacting. The variable inside your system, how the interaction of variables is happening. Which means that, for example, I am having the power is shut down. Why? I can say that the power shutdown is a variable. So I must see what causes such power shutdown. I can say that what causes such power shutdown is that I connected a very big device which consumes a very high power. This is the second variable. So I can say there is an interaction between the connection of high consuming device with the shutdown of the power. So using simulation, I can have the interaction of these two variables. And also the insight also can be obtained by the importance of variable to the performance of the system. You can see the importance of variable here. For example, the variable, the shutdown of power, this is a variable. The importance of the shutdown of power to the system is that when the power is shut down, most of the operation of my company will also stop. So this is the importance of the power shutdown, and what will be the effect to my system. They can be also bottleneck analysis can be performed indication where working process, information, material and so on are being excessively delayed. We can see how some work is being delayed. About what? Because we are not using computer. For example, the power has been shut down. The usage of the computer has been stopped. Where the work will be delayed. So we can know what will happen if we don't solve such problem. Also, we can have a simulation study which can help understanding how the system operates rather than how individual think the system operates. A simulation can help us to know really how the system operates, in spite of thinking about how it operates. It means that when you think how the system operates, you are providing wrong results. But if I use a simulation study, it will prove really how the system operates. So it means that we are having the exact results. So another advantage is what if questions can be answered easy for the design of the new system. You can have some question. For example, what if? What if meaning you can ask yourself, if I do this, what will happen? If I don't do this, what will happen? These are questions, but you don't have answers. So the simulation will come to provide answers to those problems. There are some also disadvantages of simulation. So the disadvantages of simulation is model building requires special training. The simulation is not for everybody. The simulation building require special people, professionals. So they require special trainings because this is a very difficult task to do. This needs time. There must be time and experience. Those people have to have experience and also to work on the system for a long time. So it will take time to study, to learn, and also to work on such tools. There may be more than one model developed by different people, and it may become difficult to choose the one among them. You can have different models, and each one developed by a different person. So you are going to have so many models, and you won't be able to choose which one is better than others. So the decision will be confusing. Simulation also results may be difficult to interpret. There may be some results which will be difficult to interpret because those results are very tough. So this requires special people or professional to interpret such result in order to conclude. Most of the simulation outputs are random variable. Random variable. These are variables which do not have a relationship between them. So the results may be random. It means that they come by chance. So it will be difficult to distinguish whether an observation is the result of the system in the relationship of or randomness. So it will be very difficult to know if such results have been obtained randomly, or if there is a relationship between such variables. So there may be some difficulties interpreting the results. So also the simulation modeling and analysis can be time consuming and expensive. This type of modeling can take a lot of time in order to obtain the final results. It can also very expensive. It means that it will take a lot of money from you. So if it is expensive and time consuming, it will require patience for the manager and also the model designer and the developers. Also, the simulation is used in some cases where an analytical solution is possible or even preferable. Some people, they don't know how to distinguish an analytical solution and simulation. Some people will use simulation for a problem which can be solved using analytics. This is a problem. So if you use a simulation, it means that it will be time consuming and it will be expensive. But if you use an analytical solution, it will take less time and inexpensive. It will be cheap. So you have to think deeply before choosing which method to take. These are the disadvantages of using simulation. So we are going to see area of application. of system modeling and simulation. So we can use system modeling and simulation in manufacturing application. Manufacturing application means that for manufacturing companies, for example, the companies manufacturing cars, computers, can use simulation. Before designing a real car, they are going to use a model and see how the car will be working before designing the hardware of such car. It can be used in wafer fabrication or in the business processing, the business processing, or in the construction engineering, in the logistics, on airports. It can be used by military. It can be used by healthcare. They can have simulation about the tools used at the hospital, like the scanner, and so on. So this type of simulation can be used anywhere in the day-to-day life. So we are going to have some definition. We are having systems and system environment. So when we say our subject is entitled Business System Modeling and Simulation, so we will have some concept. The basic concept here is system. What is a system? A system is what? Is a group of objects that are joined together in some regular interaction or interdependence toward the accomplishment of some purpose. If you have a system, it means it is a collection of things, a collection of objects which are joined together in some regular interaction. There must be interaction between the components of the system, and those components must be interdependent. Interdependent means that one component depends to another. So it means that they work together. For example, we can have a body of a person, or human being body is a system which has different components or objects that are joined together. It means we are having legs, we are having joined to hips and the abdomen, and also you can have arms and head. This is the system. But in the system, the objects are joined and they are interdependent. It means that in order, for example, to think, you must have a brain. A brain, for example, someone is going to has kicked you out. If he kicks you, your brain will get angry. When you get angry, you will have to defend yourself. It means you defend yourself using your arm. It means that there is an interdependence between arm and brain. So if we can say also universe of Gitco, it is a system. A system, it is composed by buildings and people. And also in the system, we are having different kind of people. We can have DVC, we can have DAF, we can have staff, we can have people in the finance office, others, HODs, like that. This is a system. So all people inside UG are independent. Students we depend on the staff, teachers, and teachers also depend on you. Because if you're not there, they won't have what to do. So the component of the system must be interdependent so that they can work together to provide the output. Here we have an example. A production system producing automobile is a collection of machine components, and the workers operate jointly to assemble a vehicle. We are having a production system which produces a vehicle or cars. So this system will be a collection of machine components. Machine components mean that the car components, tires, and so on. And the people working on such machines must operate together in order to assemble a vehicle. This is a system. So a system is affected by external change. A system can be affected by external change. It means that changes are said to occur in a system environment. Those changes occur in the system environment. So here in modeling system, we can decide the boundary between the system and its environment. Here, for example, we are having the University of Gitwe. University of Gitwe can change by external environment. For example, if we are having a system, the system, for example, University of Gitwe, the working of University of Gitwe will depend of the environment outside of the University of Gitwe. How? For example, I can have another example. For example, you using this example here. It means the reason for delay in components arrival may be considered as a system environment for a production system. We can say that we are having a production company which must buy the components from an external agent. So, when, for example, I buy some computer parts from Dubai, so there may be a delay for those components to come to me. So the delay will may be dependent on what? It may be it will depend on as a system environment of a production system. It means that, for example, if there is a coronavirus in Dubai, so they want to send me the components very quickly because they have to wait that the coronavirus pandemic is gone away. In such time, there may be a delay from external environment of the system. External environment of the system, it means that it is the coronavirus event which prohibited the shipping of my products. This is a real example. So a system is composed by different components. What are the components of a system? So the components of a system, there must be entity. Entity is an object of interest in the system. Entity is an object of interest in the system. For example, we are going to record the marks of students. The mark of student. So what will be the entity? The entity will be an object of the interest, an important object. What is the important object in recording marks of student? The main object will be students. The other is mark. So we are having entity here. The main entity will be student and the marks. If we say bank, what will be the main entity? The main entity will be the customer, because this is an important object of the system, of the bank system. What will be an attribute? An attribute will be a property of an entity. An entity is having some properties or attributes or characteristics. For example, I can say a student ID. student name. These are attributes of student, of the object or entity student. Activity represents a time period of a specified length. Activity represent what has been done within a time period. What is the state? The state of the system is the collection of variables necessary to describe the system at any time with respect to the object of the study. The state of the system, it is how the system now, how it is now. So we describe the system, how the system is. For example, if you have a University of Gitwe is working now, its state it is in a working state. We can have also an event. An event is what? It is an occurrence. It is something which happen inside the system. If it happens inside the system, it will change the state of the system. For example, here there is an event of fire inside your vehicle. You're running a vehicle. There is a fire inside your vehicle. What will happen? The vehicle was moving. It will immediately stop. So the event of the fire coming inside the vehicle will stop the working state of the vehicle. You can have also endogenous. Endogenous means it describes activity and events occurring within the system. Activities and events. For example, in the University of Gitwe, we are teaching. These are activities. Teachers are teaching. Events, it means we are having, for example, graduation. So events and the activities are related. So if we are having such events which are occurring inside the system, we can call it endogenous. Endogenous means activities and events occurring within the system. Exogenous, this is the opposite. It means the activity and events occurring outside the system. It means that in the environment which is outside the system. But what is exogenous? These are activities and events which will change the state of the system, even if they are not occurring inside. So we can have the example of such component. The first example is banking. In banking, we are having a system which is called the banking. The entities are customers, which are main object. Attributes, we can have a account balance. And activities, these are what is going on inside. We can have people making deposits. It means that we are having customer which has an account balance. He is making deposits, or he is depositing new amount to his account number in the bank. So the banking will be system, entities will be customer, attributes account balance, and activities will be what the entity is doing. He is depositing money. The event, it is the event or arrival event, where the customer is coming inside the bank, into the bank. It is the arrival event. When he goes out, it will be departure. Then there will be some state variable. State variable, it means that these are a variable which describes the states of what? The states of entities. For example, the number of visitors. These are state variables, or number of customers waiting. These are state variables. It means they show the state of the system at the current at any specified time. We can have also another example. For example, if we say, for example, communication is here. The system is the communication. The entity is the main object in the communication. These are the messages. What are the attributes? You can have a length, of the message or the size of the message and its destination. Then activities, it means if we are in a communication, we can have an activity which is called transmitting or transmission. This is an activity. Then what is an event? It means the occurrence. It is arrival at the destination. Yeah, this is an event. So state variable will be number of messages waiting to be transmitted, or you can have also number of messages which has been successfully transmitted. Here we can have also another event, the failure of the message to arrive at the destination. This is also another event. Activity transmitting, I can put receiving also, no problem. If I have a link for a destination, I can also have the type of message. It can be SMS or multimedia of a message. Entities, I can say a message or calls, no problem. Yeah. So the system will continue to be communication, no problem. So these are examples which shows the main component of the system. So now we continue to see what type of system exists nowadays. We can have discrete and continuous system. So we are going to see the difference between them. A system can be discrete or continuous. So what is a discrete system? A discrete system is a system in which state variable change only at a discrete set of points in time. Then here, what does it mean? It means that a system has variables whose state change only at a discrete set of points in time. So it doesn't change continuously. It changes sometimes it doesn't change. The next time it changes. Sometimes it doesn't change. So and so on. For example, what does it mean? For example, we are having the number of customers in a bank varies only when either a customer goes out or comes. It means that here, if there is no customer coming and going out, the system state will not change, will be stable. So this is a discrete system because it will take sometimes without changing, and it will change after some time. So only if there is no customer, it will stay unchanged. If a new customer comes or goes out, the number of the customer will decrease or increase. So it will change accordingly. This is called a discrete system. A continuous system, it is a system which will continue to change over time. It will continually change forever. Here, for example, we're having the water level in a dam may vary due to inflow, like heavy rain, or outflow, like opening gates of a dam. Here we are having an example when we are having heavy rain, the water in the dam will continually increase. So when we are going to make outflow, it means that we are opening the gates of the dam. So what will happen? The water will go out from the dam. So the water will continue going out as long as you open the gate. So this is a continuous event. So this will be called a continuous system. So a discrete system, it will change. As you can see, we are having a time here. I can put 1 second, 2 seconds, and 10 seconds. And here I'm having number of customer waiting in a line. For example, let's use minutes. 5 minutes, 10 minutes, 15 minutes, 20 minutes. Here I am having number of customers. when I am having, for example, I am having at 10 minutes, I am having, for example, 0 customer. Okay, no problem. At 20 minutes is here, I am having 1 customer. And at 15 minutes, at 10 minutes, I am having 1 customer. And then I continue. I can have also at 15 minutes, I am having around 1 or 2. I am having almost the same customer. It is almost the same. It means I am having the same customer. So it means between 10 minutes and 20 minutes only I am having the same customer. So it didn't change. If it didn't change, it means that this is a discrete system, because it stayed unchanged for between 10 minutes and 20 minutes. It was stable. So this is discrete. But when I went at 40 minutes here, the number of customers became 2. If they became 2, it means that the system changed. So here it was stable, but at 40 minutes it changed here. So the customer became 2. So it means that it was stable previously. After some time it changed. This is called a discrete event or a discrete system. But when I come here to continuous, as the time is going on, also the head of the water behind the dam is changing. At zero, at the start, the head of the water behind the dam was at this level. So when I come here to this time, it came down. When I go here, at this time, it went there. It continued till the end. It means that, as you can see, you see that the level of water is changing continuously. So this is a continuous system. So we are going to see also what is called a model of a system. A model of a system. A model of a system is defined as a representation of a system for the purpose of studying that system. If we say a model, it is a representation. A representation means that it is not a real thing. It is like a design or a drawing. You can draw a system and represent such a system using sheets of pen and sheets of paper. If I use a model, it means that it is a representation, not a real system. It is a representation of the system. So this representation will help you to study that system. For most study, only few parameters that may affect the problem are enough in the model. Here, when you are representing the system using a model, not all parameters of the system, of the real system, will be studied. Only you are going to take the important one. Otherwise, you won't be able to represent it. If you take the whole thing, it means that you won't be able to represent the system. So what you have to do, you have to take the important and the few parameters. So models include only relevant entities. We are able to put entities which are necessary. Also the main attributes, also activities which are necessary will be put into the simulation or into the model. Otherwise, if you take everything, it means that your model will be of a very big size, so it will be useless. At the same time, the model should be detailed enough to deduce a valid conclusion about the real system. So you have to provide the details of the model in a concise and a clear manner, so that we will deduce a conclusion from what we found from the model. So different models of the same system may be required for a change in investigation. You can have different type of models here. So they can be, you can have a mathematical and a physical model. You can have a mathematical and a physical model. The mathematical model, we are going to use symbols and equation. We are going to use equation and symbols, numerical equation. So the simulation model is a particular type of mathematical. It means a simulation model is a type of mathematical model. So it means if we say mathematical model, we are able to use mathematics. If we say physical model, it can be, you can have a model which will provide a version which is larger or smaller. For example, if you are watching a virus inside the microscope, it means that you are going to have a bigger version of virus here. It will be large. But if you are watching Rwanda on a map, so you are watching a smaller version of the object. This is a physical model. You can have also a static model or dynamic. A static simulation model, it is called also Monte Carlo simulation model. It represents a system at a particular point of time, static. It means that it represents the system at a particular point of time. For example, at 9 o'clock. So at that time, the static model it represents variables which do not change, which are static. While dynamic model we present a system over a period of time. It means that it present a system which will change, which is dynamic, which will change over time. For example, here we are having simulation of a bank. Simulation of a bank during working hours of one day is an example of for dynamic simulation model. Simulation of a bank. If you simulate a bank, anytime there will be so many customers, so it will change over time, from time to time. So this is dynamic model. You can have also deterministic and stochastic model. A simulation model that does not contain random variables is called deterministic. This does not have a random variable. It means that it's a model which has variables which are not random. It means the variables which have a clear relationship between them, so they are not taken randomly. So here, what does it mean? It means that we are having known inputs and also we have known outputs. It means that if I have this at inputs, at the output I have this, so it is known by default. So we are having here an example. We are having patients at the hospital. If they have at a time known, you say that patients has to come after 30 minutes. Every 30 minutes new patients come. So here we are going to call it the system deterministic. A stochastic, we are going to have a probability. This will contain random variables. It means we are having inputs, but output can be random. So we don't have outputs. We don't know outputs at the beginning. So the outputs can differ. They can come randomly. So as the output are random, they are considered as estimates of the true characteristic of the model. As the outputs are random, these are not the value will not exactly the real value. So they will be an approximation. Here you can say simulation of a bank involve random inter-arrival time and random service time. Here, there is a very good example in a bank. We can have it that if we are simulating a bank, this is stochastic because there will be random inter-arrival of customer and random of the outgoing on. So we can have also discrete and continuous model. Discrete. These two models are briefly in the section the next section. So discrete model, we saw it that it is a model whose variable will change at a point of time, but sometimes they won't change. It means they will spend some time are changed and they will change at the following time. But if we have a continuous, it means that we are going to simulate a system which continually changes. Here we took an example of a dam. When the rain is coming and the water of the dam will increase continuously. So this is a continuous model. Here also we can have discrete event simulation, system simulation. Discrete event system simulation. Discrete event system simulation is the modeling of the system in which the state variable changes only at a discrete set of input in time. In this method, the simulation model are analyzed by numerical method rather than analytical methods. Here, if you use a discrete event simulation, we are going to use the concept that the state variable changes only at discrete set of points in time. It means that they will change at a time and then remains unchanged at the next time. Here, an artificial history of the system is generated from the assertion observation are collected for analysis and the system performance is estimated. Here we can have the history of the system. We can generate the history of the system, but it will be generated from assumption. After having assumption, we will observe the results, and then after observing the results, we will analyze them. After analyzing them, we will estimate the performance of the system. It means according to data generated, we can evaluate the performance of the system according to what we have found. So we are going to see the steps in a simulation study. What are the steps in a simulation study? So while simulating, you have to follow some steps. So it is a progress task. What are the steps? As you can see on the figure, there are so many steps which must be followed in order to provide good results. First one is problem formulation. You formulate the problem. First, after formulating the problem, you have to know what is the problem you have, to which you have to find the solution. After that, you are going to set the objective. What are the objectives for my study? After setting the objective, you are going to provide what is the plan you are going to follow during your study. The plan, the overall plan. After that, you are going to do what is called model conceptualization. Here you are going to provide all concepts which will be required to define your model clearly. So this the main concepts of your model will be detailed, which will help you to study very well your system. After that, what you are going to do, you have to collect data. After collecting data, till here, you did not enter into your system. You didn't go into details. So to go into details, you have to translate your modem. To translate your modem means that from here you have studied your system using paper sheets. For example, you can use the boards or paper sheets here. So you have to translate your model. So what you have written on the board or on paper sheets must be translated into computer understandable format. So you are using model translation. After translating a model, you have to verify if the translated model reflects what you have defined here on sheets of paper. So you will ask yourself this question: did I verify the model translation? Does it reflect what I had on the papers? If no, you will continue translating here. If you are not finished with verification, you will continue with the model translation. If you are finished, it means that you will go to the second question. The second question meaning validated. If you verified it, everything is okay, you have to check if you have validated. If you have validated your data, if not yet validated, you will go again in model conceptualization here, and then continue. If you have validated your system, it means that you can go to model conceptualization or you can go to the data collection, no problem. For example, here you will go to the data collection if the model conceptualization has no problem, or you will come here if data collection there is no problem with data collection. So if it has been validated here, you will go to experimental design. Experimental design means that you are going to design your system using professional skills. After designing your system, you are going to production, run and analysis. So after designing, you are going to run your system and then analyze it. To run it means that you have you are finished with the design. So you have to run the system to see if it is working properly, and then analyze. Analyze what? Analyze how it is working. After analyzing, if you will ask yourself a question, saying, do I need more runs to check again? If yes, okay. If yes, you go to production, runs and analysis. Otherwise, if you do not need more runs, it means that you are sure that the results are okay. So you are going to write a documentation. Documentation means that this is a document which is going to explain how your system or how your model is working. So it will guide some people in the future to read and to know how you have designed and implemented your model. And then you will report it. You will provide a report of the result you have provided. The report must be written in your documents. After that, you will implement it. To implement it means that your system, you have found a report. You see that your system will work very well. You implement it. To implement it, it means that you go to the field and you implement such system, the real system, according to what you found in your simulation. So here we are having a deep explanation of each step, so we can revise it, we can revise them. So here there is a problem formulation. As I said previously, every study should begin with a problem statement. The problem statement must clearly be understood by both the policymaker and analyst. So when you are going to design your model, the first step is to raise the problem. You have to know which problem do I have. To which problem I have to provide the solution. So this, the policymaker and the analyst must define clearly the problem. After that, if both of them agreed upon the problem statement, there may be some reformation for the problem. It means you can define the problem at the beginning, but when you are in a progress, you are progressing with your system study, you find that you have defined the problem wrongly. So it may be necessary to reformulate your problem. After reformulating your problem, you have to set the objective. So you are going to set the objective for your study. You are going to say, this project aims at doing this, this, and this. And also you are going to define the overall project plan. What you are planning to do during your project. Here there must be some question. What a question to be answered by simulation model. If when you are setting objective, you set also the question to be answered by the simulation model. Here you will ask yourself if the simulation it will be necessary to find solution to the problem. Here we can have a plan Z. So we will study about the employee or people which will be required when we are designing or implementing the project. What will be its cost? What the time will be required to complete the study? So what are the expected results? All of this must be studied in the second step, setting the objective of the study. What is a model conceptualization? Here we can start building a simple model and then enhancing it with a greater complexity. Here you can start with a very simple model, and then as the time goes on, you will see that the system is becoming greater complex. So to be sure that your project will be successful, you should include users. The users of your model or for your system must be involved. Why? Because the users will give you their wishes, how what they need, how they wish the project would work for them. For example, you are designing a project for a company. You are building a project for students in UG. What you have to do, you have to involve students. You tell them, what do you need? You need, for example, they need to find the results they mark online. You have to ask them, how do you want the project or the interface would look like? They tell you, we need that the project look like this. So if you know what they need, you will design the product according to their wishes, so they won't be any misunderstanding in the future. This will help improve the quality of the model. So the quality of the model will be improved according to the user's wishes and information, and also it will increase the confidence of the user while using it. It means that the users will feel okay when they are using your system because you have designed the system according to their wishes. The fourth step is data collection. Here we have to collect data. Building a model and the collection for inputs data are intertwined. It means that when you are building a model, you have also to collect some data for input. So all this operation go together. That is, at the complexity of the model change, the required data elements also can change. Hence, data collection may take a huge amount of time of model building. You have to collect the data. The data will help you build your model, but the data can change over time. So you have to make sure that when the data change over time, you will be able to handle the new data. Here you can also translate the model. The model translation. The models of most of the real system require information storage and computation. Hence, the model must be entered into a computer recognizable format. Here, for example, I am having a data. I am having tables. I have drawn tables on a paper, on sheets of paper. I design tables having a list of customers on a sheet of paper using my pen. So those sheets of paper are not understandable by computer. So I have to type such data, refer to the data present on the sheets. I take the same data, I type it in Microsoft Excel. So it means that I am taking data from the sheet of paper into the computer, so that in the computer recognizable format, because I am taking data from the sheets into the computer. So this is called model translation. I am translating the model from sheets of paper and converting them into the computer recognizable format, into Excel format. So here I have to ask myself for the question: are those data verified, and see that if those data are valid or not? So the verification pertains to the computer program that has been prepared for the simulation model. One has to verify whether the computer program is working properly. I have to check if my computer is working. I have to verify if my computer program is working properly. This will help me to get a self-getting answer. If your computer is not working properly, it means that maybe you will get a wrong answer or no answer at all. So this verification pertains to what? To the computer program, which has to provide answers. So I have to verify if it is working properly or not. I have also to validate the model. The model is compared iteratively with the actual system behavior and hence validated. If there is discrepancies, model is improved. This procedure is repeated till the accuracy of the model is acceptable. It means that we take our model, we have to compare time to time to the real system and see if there are some differences between the real system and my model. If there are a big difference, it means that my model is not valid. So I have to do what? To change and improve it. If they are exactly the same, it means that my model is valid. It means that okay, I can continue with the model. What about the experimental design? The experimental design here, the alternative model have to be designed and which model to simulate has to be determined. for each system design model that has been simulated. Few points like time required for initialization, time required for running the simulation must be noted. Based on the comparison, one has to choose the proper model. Here, this step involves designing the model. As we see here, it means that you want to design one model only. We will design maybe 2 models or 3 models, and we, according to the validation results on this 7th step, you will choose which model is better than others, and you will choose the model chosen will be used in the future. So you have to compare them. After comparing them, the best one will be used. The step 9 is the production runs and analyzes. The production runs and the subsequent analyses are used to estimate the measure of performance for the system design that are being simulated. Here, you have to run the production. It means that what you have designed, we run it. After running it, we are going to analyze the results. After analyzing, we estimate the measure of performance. According to the results obtained, we will know what are the performance of the system. After that, we ask ourselves if we need more running. It means that running a project once, it is not enough. You can run it 3 times or 5 times. So at every step, you ask yourself, do I need more runs? If yes, okay, you have to run it again to see if there are other problems. So after analyzing the complete run, the analyst must determine whether additional runs are needed or not. After that, after running the project, if everything is okay, he has to write a document which will provide information on how the system is working. So the program documentation, there are 2 types of documentation. The first one is the program documentation. This can be used again by the same or different analysts to understand how the program operates. The program documentation can be performed or can be generated by different analysts or the same analyst. So the analyst which started with the project can do program documentation, or you can choose another analyst, no problem. So this will help the modification to be very easy. Very easy. Model user also can change the input parameter for better performance. So here in the program documentation, we can provide so many analysts to analyze your system and check if there are some modification. So if there is some modification, it will be easy to make them. Also, model users can be involved to check whether the model provides the results which are expected. We can have also the progress documentation. This will give the history of the simulation project. This will provide how the simulation project was started, how it progressed, what has been done at each step, everything. The result of or analysis should be reported clearly and concisely in a final report. The result of this analysis must be defined clearly and then put into final report. So this progress report is not a final report. This will provide the progress of your project. The final documentation is this one, the program documentation. So this will enable to review the final formation and alternatives, results of the experiment and the recommended solution to the problem. The final report provides a vehicle to certification. It means here we will be able to review the final formulation. and the results of experiments. So the progress report will help you to show what the result at each step you found. After that, the final report, this one, will certify that the project has been completed and has met the user's requirements. The 12th step is implementation. The implementation means that you have finished the simulation part. You are going to implement your project into the real field. Here, what we are going to do. The success of implementation depends on the previous step. The implementation will be successful according to the step which have been done previously from the previous progress. If the model user has been involved in the modeling building process, if she understands the nature of the model and its output, then the implementation will be enhanced. As I said previously, you have to involve the customer or user, the person who will use the system. If at each step the user is involved, it means that the final system will be enhanced, because the user will show you what is the problem, what must be done or not. The simulation model building process can be divided into 4 phases. Here, as we saw that we are having 12 steps for simulation modeling building. Here we have 12 steps, but these 12 steps can be summarized into 4 phases. So you can use those 12 steps, but you can summarize them into 4 phases. The first phase will be composed by step 1 and step 2. Step 1 and step 2 is problem formulation and setting the objective. So the first phase is composed by problem formulation and setting of objectives. It means that this is the period of discovery or orientation. You are still discovering, because you have to define the problem and the objectives. You are still in discovery. You have to think what should be done in the future. This is also after discovering, we find the orientation. The orientation will help you to know how you have what you have to be done, what you will do, how you will do it. The initial statement for the problem is usually fuzzy. At the beginning, the statement of the problem is fuzzy. So you will define it, redefine it, modify it, and so on. It must be reset. It can be reset, and the original project plan may be to fine-tuned. It means that you can define an objective. After that, you will see that the objective is not appropriate. You can change it. You can define it. You can retune it, and so on. So that is why you are still in discovery and orientation phase. There's the calibration and clarification could occur in this phase. It means that you must provide a clear statement of the problem and a clear objective of the study. So you have to go to the third stage after clearly defining the objective and statement of the problem clear. After that, you go to the second phase. The second phase will consist of step 3 to 7. 3 to 7, it means model conceptualization, tier 2 to checking the validation of your model. Here there will be a continuing interplay is required among the steps. It means that you can go from step 3. You can go from step 3 to step 4. When you go to step 5, you find a problem. You will go back to the step 3 like that. As you can see on the figure here, I am here. You can be here, and then go back here. You see, this is what we call it. This is what we call interplay. It means you go back. You have to redefine so that at the end you will find a very clear project. Third phase. The phase 3 will involve learning the model. This involves learning the model. It means from step 8 to step 10. Step 8 to step 10, 80, it means that experimental design, and then to step 10, where you are going to ask yourself if you need more learning, if you want to learn the project more than once. And the last one will consist of step 11 and 12. 11 it is documentation, and 12 implementation. So here we have an implementation, but it will depend of continual involvement of the model user and the successful completion of every step in the process. It means that when you are going to implement your project, it will be successful or not depending on what? On users. If at each and every step you have involved the users, your implementation will be successful. And if you have at each step made or possible changes, so the implementation will be successful. So these are steps which are required to do what? To provide a simulation study. So dear students, this is the first part of this subject. Then you have to read each and every concept, because we will need it in the next section of this subject. So in the second unit we are going to study statistical models in simulation. So first you have to make sure that you have finished reading the unit 1, which is like an introduction to this subject. Thank you.